Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will solve simple exponential equations algebraically. That means by showing all our working out by hand. So this is an example of an exponential equation. Again, exponential because the unknown is part of the power. So how would we solve this? Well, we just have to know powers of 2 to make this a lot easier. 32 is 2 to the power of 5. If you don't know that, just count up by 2's. So what we actually have here is 2 to the power of x minus 3 is equal to 2 to the power of 5, which is 32. So the only way these two can be equal is if their powers are equal. So that would imply x minus 3 equals 5. Adding 3 to both sides, we get x equals 8. How easy is that? Let's look at a more complicated example. So this equation here is a little more complicated because there are more operations. So it's the same process that we use for linear equations. We want to undo everything that's been done to x, but in the opposite order to BIDMAS. So BIDMAS says brackets and then indices. So what we've done here is 3 has been raised to this power first, then multiplied by 5, and then 11 subtracted. So when we're undoing things, we're going to undo the power last. First thing we're going to do here is add 11 to both sides. So I get 5 times 3 to the power of 2 times x plus 1 is equal to 405. Now, you're all very smart watching this video. Don't do something silly like go 5 times 3, 15 to the power of 2x plus 1. It doesn't work like that. So what we're going to do to undo the 5 is we're going to divide each side by 5. So then I'm just left with 3 to the power of 2x plus 1 equals 405 divided by 5 gives me 81. So now I just have a power raised to something with x's in it. I need to write this as 3 to the power of something. I want this to be the same base. So then I can find the solution a lot easier. So 81 is actually 3 to the power of 4. So I get this. And then the powers will be equal. So 2x plus 1 will equal 4. And this is easy as to solve. Subtract 1 from both sides and divide each side by 2. And there we have it. So how do we do a question like this? 16 to the power of 5x minus 1 equals 8 to the power of 40. Well, this time we have powers on both sides. But these are different bases, so we can't just equate the powers. We can't just say 5x minus 1 equals 40. What we need to do is write both of these with the same base. Unfortunately, you just have to know that 16 and 8 are both powers of 2. 16 is 2 to the power of 4. So I can write this as 2 to the power of 4, 16 to the power of 5x minus 1. And I can write 8 as 2 to the power of 3. So 8 to the power of 40, 2 to the power of 3 to the power of 40. So the power of a power rule means I keep the same base and I multiply the powers. So I need to multiply 4 by everything. This will be 2 to the power of 4 times 5x, 4 times minus 1. So then the other one will be 3 times 40. Now this is really easy to solve. I get 20x minus 4 is 120. The powers must be equal. Add 4 to both sides. And then divide each side by 20. So I think I get 6.25. And then we're done. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.